Good morning, everybody. Happy test day. Hopefully yesterday didn't go too bad with all the video lessons. For this morning, we're going to work through a practice test. So hopefully you have this handout in front of you for Mr. Hack, and we're going to fill it out together. Make sure you have a calculator and perhaps even your multiplication chart. Start off with some true-false. A, the word zeros is another term for x-intercepts. That is true. The greatest common factor of 12x squared plus 18x is 9. Unfortunately, that is false. 9 does not go into 12. The y-intercept of that equation is 7. Hopefully you are thinking that is true. The last number, remember when it's in standard form, which is 7, is your y-intercept. This equation is written in vertex form. That looks like last unit to me, a and then x minus h squared plus k, so that is true. And the equation 4x minus 2x plus 5 is written in standard form. That is not true. That is written in factored form. Remember, standard form is this one, this is vertex, and this is factored form. So that one is false. Number 2, expand and simplify. The key to this, remember, whenever you see something squared, it's just multiplied by itself. So you want to write 2 of them side by side. And then we want to FOIL. So first times first, x squared outside, 4x inside, 4x, and then last 16. Don't forget to collect like terms, almost always in the middle. 4x plus 4x gives you 8x. So x squared plus 8x plus 16. And we have correctly expanded it, and in fact we've changed it from vertex form to standard form. Number 3, factor to find the zeros. Again, when you are trying to figure out how to factor something, step 1, always check for a common factor. This doesn't have one because it doesn't have x common to all of them, and there's no number other than 1 that goes into those, so don't have to common factor. Is there 3 terms? Yes. Is it a squared, an x, and a plain number? Yes. That means you're using either you're really good at multiplying in your head, so you're doing it the quick way, or you're going to use the box window method. For the sake of everybody, I'm just going to do the box method. So remember, you're making that shape. Ax, the first thing, ax squared goes there. The c value goes there. The middle term goes there. Now you got to multiply, right? So whenever you're inside the window, you got to multiply. What multiplies to x squared? X and x. And then remember, this is trial and error. So you could try 12 and 1. You could try 3 and 4. You could try 6 and 2. Just like yesterday, for the sake of doing this correctly the first time, I'm just going to give you what the answer is. So let's say you tried 6 and 2. X times 6, 6x, x times 2, 2x. Now that doesn't give you negative 4, but we're close. If we make that negative, negative 6 plus 2 is negative 4, and if we make that negative, this has got to be negative. And then make sure you double check this column right here. Negative 6 times 2 definitely gives you negative 12, so we know we factored correctly. So your factors, remember, are the diagonals. X minus 6, x plus 2. And then from yesterday, the zeros, remember that's what makes each bracket 0. So from your first bracket, what value of x will make that 0? So what minus 6 is 0? 6. 6 minus 6 is 0. What makes the second bracket 0? What plus 2 is 0? Hopefully you're thinking negative 2, because negative 2 plus 2 is 0. Number 4, what is the equation for the axis of symmetry? Now that is written in factored form, so we're not going to use the formula that we used on that summary sheet that we made, because that's only for standard form. But instead, we're going to use our knowledge that the axis of symmetry always happens halfway between your zeros. So all we have to do to start is figure out what my zeros are. From the first bracket, x equals 1. 1 minus 1 is 0. From the second bracket, negative 2, because negative 2 plus 2 is 0. Now you have to figure out what's halfway between 1 and negative 2. How do you find the halfway point between two numbers? You simply, it's like finding an average. You just add them together and divide by 2, because there's two numbers. So add them together, 1 plus negative 2, and you're going to divide by 2. Make sure that you do the top of this first. So 1 plus negative 2 is negative 1 divided by 2. You can leave it like a fraction or write it as negative 0.5. It's completely up to you. So our halfway point, halfway between 1 and negative 2, is negative 0.5. Number 5, factor fully. Remember, you're going to get your factoring flowchart as a cheat sheet for your test. So you have all of these steps in front of you. But step number 1, look for a greatest common factor first, which they don't all have x or x squared in them. So let's see if 3 goes into all of them. And in fact, it does. So if we take out a greatest common factor of 3, that leaves us with x squared minus 6x minus 16. What's left in brackets is a trinomial, 3 terms, x squared, x plane number. So we know that we can use the box or window method. Remember, x squared goes there, your last term goes there, and your middle term goes there. Two things multiply to x squared, x and x. Two things that multiply to 16, could be 16 and 1, could be 4 and 4, could be 8 and 2. Let's try 8 and 2. Now we're really close. 8 plus 2 is not negative 6, but if we make that 8 negative, if we check on our calculator, negative 8 plus 2 is definitely negative 6, and if that's negative 8, that's got to be negative 8. And again, don't forget this 3 that we common factor out, it's got to go out front. And our diagonals, x minus 8 and x plus 2. And we have factored it. Remember, for your tests, if you have extra time, you can always FOIL these to check and make sure you get the same question back. So never really should be any guesswork. B, step 1, check for a common factor. They don't have x in them both. Let's see if 6 goes into both. It does. So if we take out the 6, divide everything by 6, that leaves us with x squared minus 9. Now that doesn't have 3 terms in it. It has 2, separated by a minus. And do they both have nice square roots? If you double check it, they do. 9 has a nice square root of 3, so this is difference of squares. And remember, it's always going to look like this. 1 positive, 1 negative. Doesn't matter the order. What's the square root of x squared? X, so that's x and x. What's the square root of 9? That's 3. 3 and 3. And we're done. We have factored it. Number 6. So this is the big scaffolded question that we did in our lesson yesterday that I mentioned you might see pop up again in an important place. So we're doing it again in our review. You might see it later today. So we have a parabola. Here's the equation. 3x squared plus 12x plus 9, and we want to go through all the steps to be able to graph it. So the first thing we're going to do, we're going to factor it. Always check for our greatest common factor, in this case 3. And when you do that, that leaves you with x squared plus 4x plus 3. You're not done. What you see in brackets, 3 terms, squared x plain number, that means box or window method. Or the quick way, if you're good at doing it quick in your head, x squared, 3, 4x. What multiplies to x squared? X and x. This one's pretty easy. What multiplies to 3? There are only 2 numbers, 3 and 1. 3x and 1x. 3 plus 1 is 4. We're good. So this final factored form is 3, your diagonals, x plus 3, and x plus 1. B, the roots. The roots is just another word for zeros, which is another word for x-intercepts. What's going to make the first bracket 0? So what plus 3 is 0? That's negative 3. And then what's going to make the second bracket 0? So what plus 1 is 0? And that is negative 1, because negative 1 plus 1 is 0. The axis of symmetry. So we have 2 different ways of doing this. You could think of it as being the halfway point between negative 3 and negative 1. And really, you don't even have to do any work for that. Hopefully, if everyone sits there and thinks about it long enough, the number that is halfway between negative 3 and negative 1 is negative 2. So you can go, if it's that easy, you can just go straight to your answer. Or, using that formula from a couple days ago, the axis of symmetry equals negative b over 2a, which in this case, my b value, right, there's b right there, is negative 12 over 2. There's my a value, which is 3. And 2 times 3 is 6. And negative 12 divided by 6, negative 2. And those are the exact same answer. You can pick your poison for what you want to do. Doesn't matter. We're going to scratch out this y-intercept reflection point. We didn't end up doing it in our video lesson. It's not a big deal. The y-intercept. The y-intercept, you can read it right off the original equation. So again, we're looking back here at our original equation. It's the c value, which is 9. So my y-intercept is 0, 9. The optimal value. So remember, the optimal value comes from your axis of symmetry. So we had as our equation, it doesn't matter which equation you pick. Let's just say you pick the factored form, which I believe was this. So 3x plus 1, x plus 3, and we want to sub in our axis of symmetry, which was negative 2. So you want to replace all of your x's with negative 2's. And you can enter that into your calculator just like you see it, or if we go through all the steps, take care of the brackets first. Negative 2 plus 1 is negative 1. Negative 2 plus 3 is 1. Multiply all those values together. You get negative 3. Your vertex is your axis of symmetry. So negative 2 with your optimal value. So there's our vertex. The step pattern. Normally we have 1, 3, 5. We multiply by our a value, which in this case was 3. 1 times 3 is 3. 3 times 3 is 9. 5 times 3, 15. And then we're going to graph all those things. So first thing we should put on x and y axis, I already gave it to you. Your zeros, negative 1 and negative 3. So negative 1, negative 3. Our vertex, -2, -3, -2, -3. And that looks halfway to my 0, so we know we've done it correctly. My y-intercept was 9. So that's all the points we have so far from all of the work we did. But we know our step pattern, 3, 9, 15. So over 1, up 3, over 1, up 3. That's perfect. That's a built-in self-check, so we landed right on our x-intercepts. Over 1, up 9. There's another self-check. We got our y-intercept. Over 1, up 9 on the other side. So right there. And we can't fit the last step on, that's okay. Smooth parabola, and then don't forget to label your equation. Doesn't matter which form you use, the standard or the factored. Since it's right there in front of me, I'll just use the factored form. And there's all of the steps that we had to take to be able to graph something from standard form with all the key information to put our parabola on our graph. Again, make sure you know how to do this. It's a lot of steps. It's potentially a lot of marks. Number 7, write a simplified expression for the area of this composite shape. It's just made of 2 rectangles. So we did a question like this kind of in our first quadratics unit, except for I asked you for the perimeter. This time I'm asking you for the area. So you're going to have to split this into 2 different shapes. There's no right or wrong answer here. One way, though, requires less work than the other. So I'm going to split it this way. And I'm going to call this area number 1, and I'll call this area number 2. How do you find area of a rectangle? Length times width. So we'll do number 1 first. So area equals length times width. Doesn't matter what you call length, what you call width. So we have, we'll say that's the length, 5x plus 4. Our width, x plus 6. And how do you multiply those two things? We've done it lots. You FOIL. So first times first gives you 5x squared. Outside, 5x times 6 is 30x. 4 times x is 4x. 4 times 6 is 24. Collect like terms. Right there, 30 plus 4, 34x, and then plus 24. So there's our expression for area of rectangle number 1. Let's do rectangle number 2 over here. Same thing, it's kind of a rectangular shape, length times width. Doesn't matter what you call what. We'll say length is 2x plus 1, width is x plus 3. How do you multiply 2 binomials? You FOIL. First times first, 2x squared. Outside, 2x times 3 is 6x. 1 times x, 1x. 1 times 3, 3. So there's our first outside, inside, last. Collect like terms. That's our middle ones. 2x squared plus 7x plus 3. So we have an expression for number 1. We have an expression for number 2. I want, though, the total area. So I'm going to do the total under B here. So if I want the total area, I just have to add all those things together. So like terms, so I got a 5x squared here, 2x squared here, that gives me 7x squareds. And then I got a 34x here and a 7x here. If I add those together, I get 41x. And then I got 24 and 3. If I add those together, it gives me 27. So there's my total area. And I want to determine what it is when x is 8 centimeters. So I'm going to put 8 in everywhere that you see x. And then using your calculator, you can enter it just like that. And after you've entered it into your calculator, hopefully you get, I think you should get 803, and then our units would be for area, centimeters squared. Number 8, so we're getting into some Word problems. The height of a water balloon thrown from the top of a building is modeled by this equation. H is height in meters, T is time in seconds. What is the height of the building? The height of the building is the same thing as asking you for the y-intercept. Now I've given you a hint here. You could put t equals 0, and if you put 0 in for all those t's, you're going to get the same answer as you would as your y-intercept. So if we look at this equation, hopefully everyone, you see a squared, a plain t, and then a number. Your c value, the one that doesn't have a t, is your y-intercept. That's the height of the building. So that would be 20 meters. If you forget that, and you want to use my hint, t equals 0, then we would do this. Wherever you see a t, put a 0 in. 0 times anything is going to be 0. Same thing here. Plus 20. 0 plus 0 plus 20 equals 20 meters. Factor the expression for the height of the water balloon. So we want to factor that. First thing, is there a common factor? Yes. And remember, whenever this first number is negative, you want to divide everything by the negative. So we're going to divide everything by -5. And that's going to leave us with t squared, and then -3t, and then -4. Now what you see left over in brackets, 3 terms, squared, plain letter, just a number, you're going to have to use this guy. So t squared, -4, -3t. Only 2 things that multiply to t squared, t and t. Now here we have some options. You could pick 4 and 1 or 2 and 2. Remember, it doesn't matter if you get it wrong. Just scratch it out, erase it, try a different combination. Let's try 4 and 1. 4t, 1t. Now 4 plus 1 is 5. We gotta get -3. But if I make that a -4, -4 plus 1 is -3. And if that's -4, that's got to be -4. Your final factored form. Don't forget about that -5 we divided by. And then your diagonals, t plus 1 and t minus 4. What's the height of the ball after 4 seconds? All we have to do is put 4 in. And then I'll show you a different way you could do this. So we're going to put 4 in everywhere we see t, because it says 4 seconds and t represents time. And if you go through the math and type that all in, so 4 squared is 16 times -5 is -80. 15 times 4 is 60 plus 20 is 80. Again, you could just do this all in one step on your calculator. You get 0 meters. So the height of the ball after 4 seconds is 0 meters, meaning it's on the ground. If we look at our factored form, if we look over here, we kind of already knew that. If I was to ask you what the zeros were, you would have told me the 0 from that is 4. 0 meaning it's on the ground. It has a height of 0. So at t equals 4, we had a 0. It was 0 meters high. We just back that up by doing the actual math, subbing 4 into our original equation. If this was a test question, I wouldn't care which way you did it, sub in the number. If you make the connection to the factored form, by all means, just say the height is 0, and I know this because one of my zeros was 4 seconds. Number 9. The area of a rectangular garden is represented by this equation. We want to factor it to find the length and the width. And we're going to specifically say which one's the length and which one is the width. So I see 3 terms. Look for a common factor. There isn't one other than 1. So we're going to go right to this. X squared, 45, and 14x. 2 things multiplied x squared, x and x. Things that multiply to 45, you could try some different things. I like 9 and 5. 9 plus 5 is 14. 9 times 5 is 45. It works. So when I factor this, diagonals, x plus 9, x plus 5. Now we want to specifically say which one's the length and which one's the width. Doesn't matter what order you put these in, but I'm going to call that the length, and I'm going to call that the width. Because part B says if x equals 3, what's the width and what's the length? So the length is x plus 9. That's what I said the length was. And we're going to put 3 in. 3 plus 9 is 12. The width we defined as x plus 5. Put 3 in for x. 3 plus 5 is 8. So we found our length, we found our width, 12 and 8. The last question that we are going to do together, the x-intercepts of a quadratic relation are at -5, 0, and 3, 0, and a equals 4. We want to write it in standard form. So, there's a lot going on here. First thing is, I gave you the x-intercepts, and if I gave you the x-intercepts, you have to make the connection that x-intercepts, another word for zeros. And if I give you the zeros, the only form that goes with zeros, remember vertex goes with vertex form, y-intercept goes with standard form, zeros goes with factored form. So let's start there. X minus s. Sorry, I was looking at the 5. Now I told you what the a is. I told you a is 4. And we know that's going to be x, and we know that's going to be x. So if there's a 0 at -5, remember stuff with x always tends to be opposite. So if there's a 0 at -5, that means that one of these has got to be plus 5, because -5 plus 5 gives you 0. So this kind of goes with this one, because again, -5 plus 5 is 0. Now we have another one at 3, which we're going to tie into this. If I have a 0 at 3, that must mean this has got to be -3, because 3 minus 3 is 0. Hopefully that makes sense. If it doesn't, pause it, go back, listen to it again, think about it again. Hopefully it makes sense after a couple times. Now we've effectively put it into factored form, but we want it to be in standard form. To get to standard form, you just have to distribute and FOIL. Remember, for these types of things where there's an a value, you have two choices. Distribute the 4 in first, then FOIL, or FOIL first and do the 4 last. I personally like to FOIL first. That's what I'm going to pick. You guys can do the other one if you like the other one better. So, that's an ugly 4. Let's go erase that. So we're going to FOIL. First times first, x squared, outside, -3x, inside, 5x. 5 and -3 is -15. Don't forget, when we're doing this, it's a simple mistake. We're always multiplying when we do this. We're never just adding. Collect like terms. -3 plus 5 is +2. Now distribute the 4 in. 4 times x squared, 4x squared, 4 times 2, 8x, 4 times -15 is -60. Even though I didn't specifically ask you on many of the questions, just as a quick review, what's my y-intercept? Right there, -60. Does this open up or down? We look here. Since that's positive, it opens up. You could say it's stretched. Your step pattern would be 1 times 4, which is 4, 3 times 4, which is 12, and 5 times 4, which is 20. So that's a good review. You have your test coming up very soon this morning. You guys got this. You did really, really well so far. Everything's going to be fantastic. Positive mindset. Go back over some of the questions I've told you to stress. Try them on your own. Make sure you've gone over how to factor. If you need a multiplication chart, you can have a multiplication chart. Don't forget your cheat sheet. You guys are going to do great on your test. Best of luck. And then when we talk again later this afternoon, we'll be starting into our third and final unit before the Christmas break.